Hi everyone. So today we'll discuss about the backtracking. I know you all have some problem in the backtracking. The biggest problem which I have seen is people are not able to debug the questions which they have solved using backtracking. They find it very difficult how to debug because there are a lot of calls and so there are a lot of recursive calls will be there. So it is very difficult for them to understand at which stage we had the problem. Okay, so I will explain you from basic. If you are completely beginners, do not worry about that. I'll teach you from zero level. Okay, so let me jump to that one. So first question is, these are the very important backtracking questions for the interview purpose. So like how to print all the permutations, knight tour problem and queen problem, subset problem, Sudoku problem. And Sudoku problem, actually I went for the two product based company interviews. There they asked me this question. So same question, two different companies ask me. So you can think of the how much important it is, how much important this topic is for the product based coding round. Okay, so you should not miss that one, and you should be master in the backtracking, because if you are not master of the backtracking, you will have problem in solving the tree questions, because in tree everywhere we are just talking about the backtracking. We are using the recursion and the backtracking, so that is the key of the, you can say, data structure algorithm. All right, let's jump to the, before going to the backtracking, I want to tell you what is recursion. So if you know, then fine, okay, you can move forward. And if you don't know, let us check this part first. So recursion is nothing but whenever a function calls itself, that is known as the recursion. Okay, for example, let's say you want to add the numbers from 1 to n. What you will do, this is iterative way, you will just run a loop from 1 to n and you will get the sum. Nothing is there in this one. Can we try the same logic for getting the sum from 1 to n with the help of recursion? Yes, we can do. How? Just check this method. There is one method call I'm doing get sum. I'm passing the first one as the input. Now what we want to get sum from 1 to n. So in this function, what I'm doing is I'm applying one check. What is this check? This check is very important for any recursive algorithm, any recursive method. Base case is very important. If you will not write the base case, it will be infinite loop, because what we are saying is in the recursive function, a function calls itself. So you will keep calling, it will never end, right? So if you really want to keep it and it at some point, so base case is very important. Now what I am doing here is I am applying if I is greater than n, just return, else calculate the sum plus equals to I and call the same function with I plus 1. That way I will, from 1 I will go for 2, I will be 3 and so on, and when I will become n, I will just get the sum. For n plus 1 it will just return due to the base condition, which is false, which is true, and it will go inside this if and it will return. So after this function, if you will print the sum variable, sum is nothing but the actual sum of 1 to n. That is the recursion, right? So for the recursion, you can note down there are three important things. First important thing is what will be the input of your method. Second important thing is what will be the base case of your method, so that you need to stop the calling of the method at that point. Third thing is what are the things you want to do before calling the method or after calling the method, depends on the questions. Understood? Let us jump to the backtracking. Then what is backtracking? Backtracking is nothing but an algorithm technique which is used to solve the problems. What it use recursion. That's why I discuss about the recursion first, because backtracking is the technique which will use recursion always. Okay, perfect. Now you will say, hey sir, when to use the backtracking, when you should use, and I'm not able to figure out. You have seen this issue. You don't know for which problem I need to use the backtracking. So what is the simple concept? Let me tell you. Normally it is used when you are faced with a number of options. And out of those options, you need to choose some options, or the one options depend on your question requirement. Okay. This procedure is repeated over and over until a final state. That's why we are using recursion here, because for one set of options, I need to do something. I will choose one option from them. I will go forward. Again, I need to apply the logic. I need to choose one option and go forward. So that is the kind of thing is simple terms. Let me tell you in simple terms when to use backtracking. Whenever you need to figure out all possible options, first thing. Second thing, out of all possible options, you need to figure out you need to choose based on the some requirement. Okay, I'll discuss with one example. So, and out of all possible solutions, you need to find the solution which is optimized or which is matching the criteria actually. Then you can think about the backtracking, that I can use the backtracking here. All right, let us solve one question and we will write down the code of this particular question and everything will be clear to you. So what you need to do is just wait and just watch the complete video if you really want to master the backtracking concepts. So in this question, what we are saying is we will have an array. Okay, that array will have the integers. Now we have one sum as the input. In this example, it is 53. You need to print all the subsets whose sum is same as the given sum. Let's say subset is the elements. Subset are the element which can be from anywhere in the array. Means that should not be contiguous. They can be contiguous, they cannot be contiguous, it depends. So subset is nothing but any random elements from the array we can pick and we need to get the sum. So here let's say 15 plus 22 plus 16 will be 53. Similarly, we have one more combination 15, 14, 16 and 8. So this way we got three combination, three subset whose sum is same as the our given sum. So in this question, you need to print these three subsets. If you will change the input, you can find more. So here that is the problem. Okay, that is the question. Now why we need to use backtracking here? Because what we are doing is we need to find all possible subset, and out of all possible subset we need to select few subset whose sum is matching the our given sum, right? So that is the requirement I told you when to use backtracking. Out of all possible solution, if you want to figure out one solution or the few solutions, then we can think about the backtracking. Understood? Let us jump to the coding part directly. Okay, we have this as the input and we have sum. We need to find all possible subset whose sum is same as the given sum. So how to start? You need to understand how I'm thinking about the problem and how to start writing the code. How to understand the things. Just keep watching and trying to learn from me. So here what I want, I need to find all the subset first of all, and then we will print based on the condition. Let me write one function which will, let's say, nothing but the print subset. Okay, print matching subset, let's say. All right, in that what you need to pass? Definitely we need to pass the array, because without array we cannot do anything. Without sum also we cannot do anything. All right, let's say I am passing these two things, and I can pass the size of the array, which is nothing but array dot length. All right, so let me define this function is nothing but the private static void, and I'll just copy paste just to save time. All right, array let's say sum, and we have the int as the size of the array. Right, now what we need to do, we need to find all the subset, all possible subset. Out of all possible subset, if one subset sum is same as the given sum, that is our answer. All right, So now how to start thinking about the problem? I'm not getting what to do. Okay, so what we have here, let's say we are at the first element. Okay, now this element can be part of the subset or not, I'm not sure. So I need to take both the possibilities. I need to take one possibility that I will take 15 as part of the subset. Second possibility is I will not take the 15 as part of my subset. These are the two possibilities only. Do you think any we have some other option here? No, right? So we have two options. I can take 15 or I cannot take 15. So let's go and write down. I can take 15. I can take the 15 is nothing but the current element. Here there is no input which will decide for the current element. Let us pass that. Okay, so this way you need to decide what all things I need here. So let's say I'll say int current index. Okay, now here I can take current index as part of my subset. All right, and second thing is I will not consider current index as part of my subset. I will not consider it. Absolutely great. So for when you are considering, okay, where you want to store the current element, there should be something. I don't have anything. Let us pass that. So let me define one array list which will store my subset. So this way you need to think about it, what all things I need. Okay, so it will nothing but the new array list. Okay, this is our input. Let us pass this as the last parameter. All right. So let me take here as the input array list integer, and I will say, let's say my list. Okay, what you are saying in the first case is I will take current index as part of my subset. So let us add to the list. So list dot add, you will say array of current index. All right, that means I have included the current element as part of the my list. All right, what error we are getting here? Local variable. Oh, this is current int. Yeah. Okay. Right. So we have added current element to the list, which is my subset. Now, after taking, you need to go for the second one, second element, and again you need to think about these two possibilities. So I have taken the first one. I need to call the same method with next element because current element I have already taken. So current index plus 1, which will be my second element. Again, I can at the second element there will be two possibilities: consider it or do not consider it. So I just incremented the current index by 1 and list will be same. Okay, till this point clear? Okay, perfect. Let us go for the case when we are not adding this current element to our subset. So in this case we are passing the current index plus 1, list, nothing will change. Okay, now let's say you are keep adding. Okay, you will reach to the last point. You will reach to the last of your array. So that time what condition you need to apply, because for recursive function base case is most important one. You need to write the base case. So here base case will be nothing but whenever you reach to the last. So if current index is greater than equals to size, that means I just need to return from there. We are done, right? Now this is the thing we have applied, that every element I can take it, I cannot take it. Now where we are comparing with the sum, what is the role of this? Out of all possible solutions, I want the one whose sum is same as this sum. So how to do that part? How to consider that part here? So okay, here we are keep adding to the list. One thing I can do is I can every time I can check the sum of the list. If list sum is same as the current sum, I can print the list. But that is not a good way, right? What I can do is I can take one sum as the parameter here. Let's say, let me give the name as current sum. All right. So I just passed one more parameter as the current sum, and here what I am saying is current sum. Here we are considering this particular element in the our subset. So let me add that to our current sum, okay, because we are adding it. Here in this case we are not adding it, so I will not add this element to the our current sum. Perfect. Absolutely great. Now when we reach to the end, can I compare my current sum with the our given sum? So what I will do, if current sum is same as the our sum, second parameter, you can see this is the actual sum for which we are looking for subsets. What you need to do, you just need to print the subset. For printing the subset is present in the list. So I will just say list.size I plus plus, and I will just print the our list, which is nothing but the list dot get I. Let me put some space after the loop. I'll just print the new line so that we will see that our list we should be able to differentiate between the list. Okay, right? So what we are doing here, we have reached the last. We are comparing if the current sum is same, that means list has my subset. I need to print that one. Absolutely great. Okay, let us try to run it. We'll see what will happen. Oh man, what we are getting, see, lot of elements are coming. We didn't get the things which we wanted to. Okay, that means something we missed out here. Now this I just did it intentionally because I wanted to show this, that how to use the backtracking here. Here did you see one thing? Let's say I'm adding my first element to the list. Okay, I will move to the second element, again I will come, I will add, I will reach to the last 8. So okay, you reach the 8, you will compare with the current sum and sum, you will print, let's say you will come back. So while coming back, are you removing the elements from the list? We are never removing the elements from the list which are not satisfying our criteria. This is the key. Understood, guys? This is the key for the backtracking. Because let's say you choose one path, you went from point A to point B, something is not found. Let's say you will come back, you will choose different path. While choosing the different path, while coming back, you need to revert the things which you have done. So that's why we are calling it backtracking. So while doing the backtrack, you went forward, while coming back, you need to revert the operations which you have done. So here what we have done, we have added the element to the list. We need to revert it back. So for reverting, we just need to remove the element from the list. How to remove the element from the list? We know array of current index I want to remove. So this way I just remove the current index from the list. All right. So are we clear on this part? What mistake I am doing here is, oh, this is a spelling mistake. Yeah. All right. So what I am doing, whatever element I was adding, I just removed it from the list because we are doing the backtrack. So I need to keep popping the elements out of the list. All right. Let us try to run it now. Oh, perfect. We got it, right? So first subset is 15, 20 to 16. Second subset is 15, 14, 16 and 8. Third subset is 22, 14, 9 and 8. You can compare with our output here. All right. I hope it is clear. If you want the code, I will add the code in the description of the video. If anything is not clear, okay, just check out the video again, and I would suggest try to write down the same code. Try to copy the steps which I have done. By doing, you will learn a lot of things. So just try to copy the code, try to learn what we are doing, why we are doing, can we do some other way also. There can be better way, I'm not saying no. But this is simply, I just, whatever things were coming to my mind, I was keep doing those things. And we were learning the backtracking, how the backtracking is working. So this line is very important here. Okay, that is the power of the backtracking. While coming back, you need to do the steps which you need to remove the steps which you have done previously. Absolutely great. For the time complexity, what will be the time complexity for the backtracking here? It is very important part. Here what we are doing, at every element you have two possibilities, either consider it or do not consider it. So the time complexity will be nothing but O of 2 to the power n. If you really want to understand how this is coming, we can draw one tree. You can draw one tree. At every element just try two children. Take it, do not take it. At next option also you will do two options, take it, do not take it. So don't you think we are making a binary tree? And for the binary tree, once you will see how many nodes will be there, you will understood that the time complexity will nothing but of 2 to the power n.